In every part of the country today glide diesel-powered trains. Travel triumphs of comfort, convenience, and beauty. Effortless speed, born of vision and faith. Gleaming streaks of power have caught the imagination of Americans everywhere. Electricity and gasoline have brought the 20th century far. Diesel power will carry it forward. The romantic way for Americans to travel is by rail, and diesel-powered trains make people want to ride on trains. Diesel-powered trains get passengers from one place to another in a hurry, in calm, quiet comfort. Diesel-powered trains are giving modern America modern transportation. They have proved their worth in regular service, trip after trip.
Diesel-powered trains are leading America into a new era of rail transportation. But the idea of an internal combustion engine for railway locomotion is not new. Interest in the internal combustion engine produced the engine in the early automobile and looked to its application as rail motive power. This mutual interest produced in 1905 the McKean car, manufactured by the Union Pacific. Powered with a 150 horsepower gasoline engine, it carried baggage and passengers. In designing the McKean car, the Union Pacific staff took some ideas for reducing wind resistance from the Baltimore and Ohio Adams wind splitter of 1900. Another important contribution to car design made by the McKean effort was that the structure was very strong in proportion to its weight. About 1909 came a gas-electric rail motor car. This car differed from the McKean car in that it reflected the progress that had been made since 1905 by the automobile manufacturers. The rail motor car of 1909 proved that electric transmission was a most important element in this form of transportation. The gas-electric rail motor car grew steadily in horsepower, utility, and dependability, paralleling the development of the internal combustion engine in the automobile. Until by the end of 1915, between 90 and 100 of these rail motor cars were in operation in the United States. During the war, very little was done with the problem of fitting the internal combustion engine to railroad service. But sufficient interest had been created by the electric transmission rail motor car of 1909, so that in 1924, the Electromotive Corporation found the railroad industry waiting for its first internal combustion rail motor car. Electromotive Corporation showed conclusively that a rail motor unit of sufficient size and horsepower could be built, and that it would mingle successfully with conventional railroad locomotives and cars. Horsepower stepped up from 175 to 900. Rail motor cars hauled combination passenger and freight trains on branch lines. Railroads paid $40 million for over 700 of these locomotives, 500 of them supplied by Electromotive Corporation, all powered with engines built by Winton. In 1929, Chicago Great Western Railroad brought out the Bluebird, its power plant manufactured by the Electromotive Corporation. Smokeless, sootless, cinderless, luxurious rail transportation. In 1933, after constant improvement, the internal combustion engine had approached even closer to its ultimate perfection in the automobile. Likewise, the internal combustion engine was meeting with favor for railroad service. In February of 1934, the Union Pacific City of Salina, the first streamlined train in America, powered with a Winton distillate engine, sped on its maiden run. The three-car articulated train gathered headway with the smoothness of an ocean liner and the speed of an automobile. The city of Salina was the railroad's challenge to all other kinds of transportation, a challenge powered by an internal combustion engine. Railroads recognized the importance of the internal combustion engine as motive power. By early 1933, General Motors engineers had produced a two-cycle diesel engine with unit fuel injectors suitable for mainline locomotive service. This engine was light enough and small enough to permit placing sufficient power to handle a full-size train within dimensions that can go anywhere on a railroad, such as through existing tunnels. The first train powered with this two-cycle diesel engine was the original Zephyr of the Burlington route. In April 1934, the Zephyr made its first trip. This train and the Union Pacific city of Salina everywhere were pointed out as hailing the dawn of a new age in rail transportation. The railroads had the very real problem of winning passengers. The solution was to offer speed, low fares, comfort, and attractiveness. And that solution was streamlined trains powered by diesels. Those who are fortunate enough to get reservations every day over many lines ride 19,420 miles, swelling the 7,115,683 miles that the railroads equipped with diesel-powered trains have piled up since 1933. The public cannot resist the attractiveness of these colorful arrows. Smoothly, certainly, diesel-powered trains accelerate. In a flash, they are underway. Easy starting and rapid acceleration are important factors in economy of operation. The interiors of these diesel-powered trains link swiftness of travel with truly fine living. Smoothness of operation and the absence of noise relieve the passenger of any sensation of excessive speed. Sleeping accommodations on these diesel-powered trains are distinctive, complete, and luxurious. The traveler sleeps to awake rested. New standards of beauty and comfort are set in the rich appointments of the dining cars of these modern diesel-powered trains. Passengers in the chair cars ride in the luxury of deep cushioned reclining seats, smoothly at 10 miles an hour or at 90 miles an hour. The cocktail lounges of these finest of trains are smart, sparkling, gay with ease and color, informal. All this luxury of travel, this beauty and comfort that has boomed railroad travel, speeds over the rails behind these powerful and economical and dependable locomotives of from 600 to 5,400 horsepower, propelled by General Motors diesel engines, connected directly to electric generators which supply power hour after hour at low cost, without soot, without cinders, without waste. Today, diesel-powered trains show the way. Speed with comfort, safety, and economy of operating costs. These were the aims of the builders, aims that have been fulfilled and surpassed. As is usual in the history of transportation, the more spectacular achievements lead to important improvements in more prosaic fields. And that ever-broadening field is in switching, where diesel-powered locomotives show conclusively their dependability and economy. In 1924, a group of important manufacturers collaborated in the production of a 300-horsepower diesel switching locomotive. These demonstrated their superiority over steam locomotives for many kinds of yard operations. But more important than the history of internal combustion switching locomotives is the factual report of the advantages in economy of operation of diesel-powered switching locomotives over steam. All the weight of the diesel-powered locomotive is carried in the driving wheels. This balance gives the most efficient return from locomotive weight and produces high starting tractive effort. Because of the electrical transmission, full horsepower reaches the wheels for starting and for use in lower speed ranges. These factors, weight on drivers and horsepower availability at all times, assure quick and smooth starting of loads with diesel locomotives. It is not necessary to take up the slack. Most railroad switching is done at speeds under 8 miles an hour. The maximum horsepower of a steam locomotive is not reached until the speed is about 30 miles an hour. Diesel-powered locomotives deliver maximum horsepower at these low switching speeds. Hence, 600 horsepower diesels outperform steam locomotives of 2,000 potential horsepower output. Steam locomotives, because they need more frequent and more extensive repairs, are rarely available more than 6,000 hours yearly. Diesel-powered switchers normally are available for 8,000 hours of work yearly, 330 days of 24-hour service. Electromotive corporations snuff fuel oil for 5 days operation of 24 hours each. This greater availability for work makes it possible for diesel-powered switchers to replace more than the same number of steam locomotives. Their servicing time is almost nothing. General Motors diesel-powered locomotives will operate anywhere a freight car may be handled. Diesel-powered switch engines have clear exhaust even when working hardest. There is no smoke or steam to obscure the view of the operator, and safety is added to by the absence of the fire hazard and by the more comfortable working conditions for the operator, which prevent fatigue and allow concentration on signals. The short, rigid wheelbase of the diesel-powered switcher and the uniform power application make this locomotive much easier to track. Through the high thermal efficiency of diesel engines, 1 car of fuel oil does the same switching work as 12 cars of coal. With diesel-powered switchers on the job, engine house expense fades to a minute part of that spent on steam locomotives. Repairs to steam switchers average more than repair costs to diesel locomotives of corresponding age. Diesel-powered locomotives do not have to be supported by water treatment plants, water storage tanks, fire dropping pits, cinder disposal facilities, coal hauling facilities, and coal docks. Investigation has shown that if the Class 1 railroads of America were to put 3,000 diesel-powered locomotives to work switching and work them 7,000 hours a year for each unit, they would save $52 million. This would give a return of 25% on the investment in diesel power and completely liquidate that investment in 5 years. A total of 12,000 locomotives are in switching service, 27% of the locomotive inventory of Class 1 railroads. The Class 1 inventory in locomotives built for switching is 8,000 units. And so in 1936, 4,000 locomotives originally built for road service were at work switching, work for which they were not designed nor best suited. Obviously, a steam locomotive built for mainline service is more costly to operate in switching service than one designed to meet the peculiar problems in switching. The major railroads of America can save $52 million every year by supplanting old equipment with diesel-powered locomotives designed for switching service. Add to this freedom from bother with worn-out equipment and greater ability to serve customers, the answer can only be increased demand for railroad service, greater revenues, and an assured future in which to grow and to serve. With faith in this future of rail transportation in America, the Electromotive Corporation is busy building diesel-powered locomotives in its factory at LaGrange, Illinois. Here is the majesty of manufacturing. Here is assurance that nothing can stop the progress of diesel-powered locomotives. Here, unprecedented speed on rails is built into passenger locomotives. Here, unmatched endurance and economy become inseparable qualities of switch engines. This tremendous plant is the first and largest in the world for the exclusive manufacture of diesel-powered railroad locomotives. And yet, the largest factory for the manufacture of diesel locomotives was only the beginning, and the plant additions bear out Mr. Alfred P. Sloan Jr.'s statement. General Motors is demonstrating its faith in the possibilities of the future. We believe that the present trend of applying diesel power to railroad requirements in the form of locomotives, both for road and yard service, is only in its infancy, with wonderful possibilities for growth. The diesel locomotive is spectacular, yes, and much more. It is dependable, hard-working, and economical. These are the signs of the present, which signal for the future full speed ahead.